Good morning, students. So in last class we have discussed that the special properties all are completed. Now extra properties also, reduction potential also completed. Some important compounds. See, some important compounds of D-block elements we are discussing. In this, what are that general things? Halides. So halides are there. Next, oxides. Next, oxygen and halogen combination. So that is oxyhalides. So oxyhalides also there. Next, if oxygen is combining, they are getting with charges also. See, that is oxy ions or oxide ions. So these ions, either positive ions also there, negative ions also there. See. So general oxidation state, different elements if you see based on their oxidation states. Suppose you take iron. Iron is showing Fe plus 2. So it is called as what? Ferrous. So lowest oxidation state you called as As. Highest oxidation state you called as Ic. Ferric. Suppose you take copper. Copper is showing copper plus 1, otherwise Cu2 plus 2. This is called as a cuprous. Next, Cu plus 2. It is called as a cupric. See, highest oxidation state is Ic, lowest oxidation state is As. This is. Suppose you take manganese. So the manganese is showing Mn plus 2, Mn plus 4, Mn plus 6, Mn plus 7. See, if you know the oxidation states, then you can easily write all types of the compounds. Suppose you take chromium. So chromium plus 3 is there, chromium plus 6 is there. Next, suppose you take zinc. Zinc is Zn plus 2, cadmium is plus 2. So mercury. So mercury, two types are there. So mercurous. This is also represent Hg2 plus 2. So mercurous, lowest oxidation state is As, next Hg plus 2. It is called as mercuric. Highest. Next, coinage metals are there. Coinage metals, so copper, already we see copper is plus 1 and plus 2. So silver. Silver is showing Ag plus 1 oxidation state. Only gold, it is showing plus 3 oxidation state. If you know the oxidation state, we can easily write all the compounds. So one by one we will see. First we see the halides. Halogen oxidation state is -1. So suppose iron is reacted with chlorine. So you take Fe plus 2, Cl minus 1. Your compound is FeCl2. So this is called as a ferrous. So that is a ferrous chloride. Next, Fe plus 3, Cl minus 1. 3 is coming, 1 is coming here. So you are getting FeCl3. So that is ferric chloride. Next, suppose you take a copper. So Cu2 plus 2. F you take minus 1. So that is what? Cu2F2. So Cu2 plus 2. This is what? Cuprous. Cuprous fluoride. Next, Cu plus 2, Cl minus 1. So you are getting a CuCl2. So that is a cupric chloride. 2 coming here, 1 is coming here. Next, silver you take Ag plus Cl minus 1. You are getting AgCl. Ag plus Br minus 1. So silver bromide. Ag plus I minus silver iodide. AgI. You are getting. Next, gold chloride. So gold chloride means gold oxidation state is plus 3. Cl is minus 1. 3 is coming here. So that is what? AuCl3. So auric chloride. Suppose zinc and cadmium. Zinc plus 2. Cl minus 1. Formula ZnCl2. Next, cadmium. Cd plus 2. Cl minus 1. So cadmium chloride. So if oxidation state of the element you know, so you can easily write all the compounds. So some other examples we see. Suppose manganese you take. So manganese plus 2 is there. Fluorine F minus 1. So your formula MnF2. So manganese plus 4 F minus 1 MnF4. So manganese tetrafluoride, manganese difluoride. So like that you can take. Suppose chromium is there. Chromium plus 3 Cl minus 1. So CrCl3, chromium chloride. So these are the halide examples. Next. Second, you write oxides. So second example, you write oxides. So oxide formula is what? O minus 2. So oxide is O minus 2. So here metal oxidation state is there, you can easily write it. Ferrous oxide. So Fe plus 2. Oxygen minus 2. 2 cancel. So you are getting FeO. This is called as a ferrous oxide. Next, Fe plus 3 also. O minus 2. 3 is coming here, 2 is coming here. So you are getting Fe2O3. This is called as a ferric oxide. Next, their combination also. If both you are combining, what you will get? Fe3O4. This is called as a mixed oxide. So inside you have ferrous and ferric combination. That's one. Suppose you take cuprous oxide. Cuprous oxide Cu plus 1. Oxygen minus 2. 1 is coming here, 2 is coming here. So you are getting a Cu2O. So that is a cuprous oxide. Next, plus 2 if you take Cu plus 2. Oxygen minus 2. 2 cancel. Your answer is CuO. So this is a cuprous oxide, this is a cupric oxide. Next, suppose you take silver and gold. So silver oxidation state is plus 1, oxygen is minus 2. So 1 is coming here, 2 is coming inside. So your formula is Ag2O. Silver oxide. Next, gold oxide. So gold oxidation state is plus 3. Oxygen is minus 2. So 3 is coming here, 2 is here. So your answer is Au2O3. So similar manner, so you write manganese also. See, if you take examples of manganese. See, manganese plus 2, oxygen minus 2. So 2 cancel. Your answer is MnO. One example. Next, Mn plus 4. Oxygen minus 2. Cancellation is there, try to cancel. So 2 is coming here. You are getting MnO2. Mn plus 6. Oxygen minus 2. 2 3 is 6. 3 is coming here. Your answer is MnO3. Next, manganese highest is showing plus 7. So that's why manganese plus 7, oxygen minus 2. So your formula Mn2O7. So dimanganese heptoxide. So otherwise Mn2O7. Next, you take a chromium examples. Chromium plus 3. Oxygen is minus 2. So your formula Cr2O3. Next, chromium plus 6. Oxygen is minus 2. So here what? Cancellation is there. 2 3s are 6. So you are getting CrO3. So next, these are which type of compounds? Ionic, otherwise covalent character. See, highest oxidation state. So positive or negative. Oxidation state highest. Highest positive oxidation states are showing covalent character. So lowest oxidation state, they are showing ionic character. See, suppose here chromium plus 3 is there, chromium plus 6 is there. In these two compounds, lowest oxidation state is showing ionic character. So it has more ionic nature. It has more covalent character. By seeing the oxidation state only you can tell. So manganese plus 2. See, positive oxidation state increases, the size is decreases. So large size, otherwise smallest oxidation state, it has ionic nature. Next, positive oxidation state increases, size decreases, so covalent character increases. So positive oxidation state increases, covalent character increases, lowest oxidation state, ionic character is there. So you remember that one. Next, oxides are over. Now, you take oxyhalides. See, before going to oxyhalides, so oxyions, otherwise oxide ions we are going to discuss. See, manganese, suppose this is Mn plus 7 is there. Suppose I am adding 3 oxygens, O minus 2, O minus 2, O minus 2. Then what happens? See, negative ions are 6 are there. So here 7 positives, 6 negatives. So I am writing in what way? MnO3. So 6 only neutralizes, 1 positive is there. So you write 1 positive. Okay. Suppose I am taking manganese plus 7. 4 oxygens I am taking. So then what happens? So here 4 2s are 8. Here 7 only neutralized, 1 minus extra. So that's why you write MnO4 minus 1. See, plus 1 is combining with minus, negative is combining with positive. Suppose plus 1 is combining with chlorine minus 1. What happens? MnO3Cl. So manganese trioxychloride. So oxyhalide you will get. Suppose here negative charge is there. So positive you can add. So K plus 1. So what happens? KMnO4. So you are getting potassium permanganate. So like that. Suppose Mn plus 6 you take. Mn plus 6. So 2 oxygens only I am writing. So then what happens? MnO2. 4 gone. Remaining 2 positives are there. So plus 2. Suppose 4 oxygens you add. Mn plus 6. 4 oxygens I am adding. See, 4 2s are 8. 8 negative oxygens, 6 positives. So what will be the formula? MnO4. Here minus 2. So these are what? Oxide negative charge. Oxyanion. Oxycations. So like. Next, similar example, you take a chromium also. So chromium plus 3 you take. Suppose 1 oxygen only I am adding. So minus 2. So what happens? CRO plus 1. So oxygen cation, oxycation. So chromium plus 3 I am adding 2 oxygens. So here 3 positives, 4 negatives, 1 negative extra. So that means I am writing CrO2 minus 1. CrO is plus 1, CrO2 is minus 1. Suppose chromium 6 you take. So chromium 6. So I am taking 2 oxygens. So 2 oxygen means what happens? 4 negatives are neutralized. Here 4 positives are neutralized, 2 extra are there. So that's why I am writing CrO2. Here plus 2. 2 positive charges are there. So that's why further you add 2 chlorines. Then what happens? CrO2 Cl2. Formula coming. So this famous name is chromyl chloride. So that name. So next, more than this oxidation state oxygens you are added. Suppose 4 oxygens I am adding. Then what happens? Chromium plus 6. 1, 2, 3, 4. Then CrO4. See, 4 2s are 8. 6 only neutralized. Remaining 2 are there. So you write minus 2. See, here 2 negative charges are there. Positives you add. I am adding 2 potassiums. So formula K2CrO4. So potassium chromate. You are getting the compound. If you know the oxidation states, according to this you can create that compounds. So this is oxide ions are oxycations also there. Oxyanions also there. So whatever the compound you take, less number of oxygens, more number of oxygens according to their oxidation states you can take. Okay, these are the important D-block element compounds. So in the D-block element we have 2 important compounds. So that is that only we are going to discuss. One is K2Cr2O7, another one is KMnO4. So with these 2 compounds our chapter will be completed. So in the D-block elements we have 2 important compounds. One is KMnO4, that is K2Cr2O7, potassium dichromate. So first important compound is potassium dichromate. In this every compound we are discussed means One is the preparations, another one is the chemical properties and their structures only important. So first preparation. See that chromium contained ore, so that is chromite ore. So the chromium is extracted from chromite ore. So this formula, it is a combination of FeO, Cr2O3, otherwise Fe, Cr2O4. So anyone you can take. Chromium oxide, iron oxide, combination only you are getting, that is called as a chromite ore. So in step 1, chromite ore is treated with basic medium. So basic medium means that is Na2CO3 in the presence of air. Air is nothing but oxygen. So then you are getting sodium chromate, Na2CrO4. So how to write the matter? The chromite ore is treated with base Na2CO3 in the presence of air, then it gives sodium chromate. So you write down that matter and write down the equation. For balancing purpose, equation is FeCr2O4 plus Na2CO3 oxygen. So you can write 4, 8, 7. In practice only you will get that one. So here you are getting Na2CrO4. So iron becomes as Fe2O3. Next, in this carbonate, CO2 is coming outside. So here 8 carbons are there, so 8 CO2. Next, irons are 4, so that's why you can take 2. Next, sodiums are 8 2s are, so 8. So chromiums also 4 2s are 8. So it is a balance. So this is step 1. How to write it? Chromite ore is treated with sodium carbonate base in the presence of air, then it gives sodium chromate. You write down that matter, after that you write down that equation. Next, step 2. See, the above sodium chromate is treated with acidic medium. So then you are getting the sodium dichromate, Na2Cr2O7. So you write the matter in what way? Step 2. The above sodium chromate treated with acidic medium, then they produces sodium dichromate. For balanced equation, you can take Na2CrO4 treated with acidic medium. So 2 moles, this is also 2 moles. So you are getting Na2Cr2O7 plus 2Na plus is going outside. Next, H2 is there, 1O oxygen. So you are getting H2O. So here you write down the matter. The above sodium chromate is treated with acidic medium. Here you can take either HCl or H2SO4, whatever it may be. Any acid you can take. So you are getting sodium dichromate. But actually what we want? Potassium dichromate. So instead of sodium, you convert it into potassium. So that's why in step 3, the above sodium chromate Na2Cr2O7 is treated with potassium chloride. So the above sodium dichromate treated with potassium chloride. Then potassium and sodium they are exchanged. So you are getting K2Cr2O7 plus 2NaCl. See, K2Cr2O7 is in the orange color. Next. So this is the first one is the preparation. So step 1, chromite ore treated with base in the presence of air. You are getting sodium chromate. You write down matter like that. Next step 2, the above sodium chromate is treated with acidic medium. It gives sodium dichromate. But we want potassium dichromate. So that's why the above sodium dichromate treated with KCl, potassium chloride. Then it gives orange crystals of potassium dichromate. This is the matter. See, this is the preparation. So preparation is over. Next, so we see the structures. So what are the here important compound means 2 are there. Here we have K2Cr2O7 and K2Cr4. Here we have 2 compounds. It is what? Potassium dichromate. So this is potassium chromate. See, this is treated with the base. So K2Cr2O7 treated with base, otherwise OH minus. So you are getting K2CrO4. Next, opposite. This is treated with acid. So means H plus. So it gives potassium dichromate. So one important conversion. This is very, very important. Next, so these 2 structures also important for us. Next, another colors also in the examination, their colors also important. This is orange red. So this is orange color. This is a red color. So K2Cr2O7 is in orange color, that is a red color. So that important. Next, their structures. So structures of these 2 compounds. See, first identifying the structures, we must know what is the chromium, which group it is there. So if you go through 3D series. So 3D series is what? Scandium, titanium, vanadium, chromium. So chromium we are discussing. This is the 3rd group, 4th, 5th, 6th group. So chromium is the 6th group. 6th group means maximum oxidation state. Maximum oxidation state is +6. Always you remember, depending on the group number only, it can form maximum bonds. So maximum bonds also 6. Maximum bonds means nothing but bond order also you can take. So this is minimum concept. Whatever the atom, that group number only, maximum oxidation state, that group number only can form maximum bonds. Based on this logic only, you can write the structures of that. So first of all, I am writing K2CrO4 structure. So chromium I am writing. So that is the 6 only. So one oxygen, double bond O. Next, one oxygen minus, another oxygen minus. So here O minus means K plus. Next K plus. See here, chromium, oxygens are 4, potassiums 2, and you count 1, 2, 3, 4, 5, 6. 6 bonds only. Yes, exactly, that is correct only. This is the structure. Next, who are that responsible for the structures? Here sigma bonds only. One is sigma bond, another one pi. Here one bond only, that is sigma. One is sigma, another one is pi. So total sigma bonds, number of sigma bonds plus number of lone pairs. See, actually for the structure and hybridization, these two are the important. Number of sigma plus number of lone pairs. Number of sigma bonds are 4. Number of lone pairs are 0. So that's why your number is 4. 4 means you can write sp3. See, S is 1, P is 3. 1 plus 3, 4. 4 number you are getting means hybridization sp3. So 4 are there. So you can write what? There is no lone pair. Lone pair is coming means structure is disturbed. Bond angle decreases. So the structure is tetrahedral. So already in your chemical bonding chapter of your first year. So 4 sp3 tetrahedral, bond angle is nearer to 109 degrees 28 minutes. So this is about K2CrO4. That means potassium chromate. Now we will see the structure of K2Cr2O7. So K2Cr2O7 structure. See, here also 2 chromiums are there. So I am taking 2 chromiums separately. Next, always you remember here group number is 6 means maximum bonds also 6. So here I am trying to write. So seven oxygens are there. Here I will put 3. That also I will put 3. See, 1 oxygen, second oxygen, third oxygen. So potassium are there. So 1 plus. Next, 1 oxygen, second oxygen, third oxygen, K plus. So remaining what? 2 chromiums are over, 2 potassiums are over, 6 oxygens are over. Remaining 1 oxygen is there. So I am writing in between middle. So this is K2Cr2O7. So chromium surrounded with 1, 2, 3, 4, 5, 6 bonds. 1, 2, 3, 4, 5, 6 bonds. So 6 bonds are satisfied. So this is the structure. Next here also, what will be the hybridization? 1 sigma, sigma pi, sigma pi. This is sigma. So this chromium is surrounded with 4 sigma bonds. So 4 sigma bonds, 0 lone pairs. So here also the number is 4. 4 means hybridization is sp3. One is S, another one 3. So 1 plus 3, 4. Same. So 4 means 0 lone pairs are there. So structure is tetrahedral. So in some books they can show TD. Don't confuse. So tetrahedral, the bond angle is 109 degrees 28 minutes. Okay. In next class we will discuss about the chemical properties of potassium dichromate.